In this part of the lecture, we are going to categorize different types of decision errors in conducting hypothesis testing. Hypothesis tests are not flawless. In the court system, innocent people are sometimes wrongly convicted and the guilty ones sometimes walk free. Similarly, we can make a wrong decision in statistical hypothesis tests as well. The difference is that we have the tools necessary to quantify how often we make errors in statistics. In a hypothesis test, we make a statement about which of the null or alternative hypotheses might be true, but we may choose incorrectly. There are 4 possible scenarios in the hypothesis test. 2 scenarios represent a correct decision, and 2 scenarios represent an error. If the null is indeed true, and our decision is not to reject the null, then no mistake is made. Similarly, if the alternative is true, and our decision is to reject the null in favor of the alternative, then no mistake again. If the null is true, but we decide to reject the null, then we are making a type 1 error. If the alternative is true, but we fail to reject the null, then we are making a type 2 error. Of course, we almost never find out if the null or the alternative is actually true, but we must entertain the possibility that they might be. In fact, if you recall our lecture 4, we have seen these 2 types of errors in the medical test context. Now let me talk about the type 1 error rate. As a general rule, we reject the null hypothesis when the p-value is less than 0.05. That is, we are using a significance level equals to 0.05. This means that for those cases where the null hypothesis is actually true, we do not want to incorrectly reject it more than 5% of the times. In other words, there are 5% of the chance we might reject the null hypothesis when it is actually true. That is, there are 5% of the chance we're making a type 1 error. Generally speaking, when using a significance level alpha, the probability of making a type 1 error is alpha itself. In other words, the significance level is basically the type 1 error rate. This is why we like to keep alpha to be very low. Increasing alpha would increase the type 1 error rate as well. A type 2 error occurs when a false null hypothesis is not rejected. We typically denote the type 2 error rate as beta. If we want to calculate beta, we need to specify a value for the population mean under the alternative hypothesis, as well as the rejection region for a given significance level alpha, namely the type 1 error rate. Therefore, it is a little bit involving to compute the type 2 error rate, which is beyond the scope of this course. That being said, you need to understand the qualitative relationship between type 1 and type 2 error rates. If you want to decrease the probability of making type 1 error by specifying a smaller value of a significance level alpha, then you would necessarily choose a narrower rejection region, which makes it more difficult to reject the null hypothesis. As a result, you increase the probability of a type 2 error rate. In a nutshell, you just cannot eat the cake and have it too. Reducing one of the error rates is always at the cost of increasing the other.